Hi and welcome back to ESMARConf2023. This is the third presentation session on searching and record management, part 2. As always, you can ask questions via Twitter, by following ES Hackathon, or by using the Slack group if you have registered for the conference. Presenters will be answering the questions that you pose to them after this session as well, so keep those questions coming in. Up first today is Emma Wilson, and she's going to be talking to us about the benefits of using R for systematic review reference management.
Hello, my name is Emma Wilson. I'm a PhD student at the University of Edinburgh and I specialise in systematic review methodology. This short talk is all about managing your systematic review references using R. By references, I mean information. Usually bibliographic details like the title, the journal, and the DOI, all about your publications in your systematic review, from your initial search down to your final set of included studies. This is very much a beginner talk. I will discuss the importance of managing your systematic review references, the limitations of using software such as EndNote and Excel, and the benefits of using R instead. Additionally, I will mention some R packages that can help you keep track of your systematic review references. Depending on your systematic review question or the publication rate in your field of interest, your systematic search could potentially retrieve hundreds or even thousands of references. It's really important that you can keep track of your references for your Prisma flow diagram. For instance, how many studies you retrieved in total, the number of unique studies after duplicate removal, the number of studies included through screening, and the final number of studies included in your review. Keeping track of your references is also really important if you ever want to do a systematic review update. A lot of this comes down to good data management. The last thing you want is to finish your review, get ready to publish, and you realise that you've only kept your included studies and you cannot remember how many were in your initial search results. I've seen a lot of guidance recommend software such as EndNote to keep track of your systematic review references. From personal experience, I've often struggled using EndNote, particularly when it comes to good data management. So it's not an approach that I would generally recommend. But what are some of the reasons that people do use tools such as EndNote? Well, a lot of EndNote and other reference managers features are actually quite useful to the systematic review process. It's possible to import searches from different scientific databases, and there are features to remove duplicate records and retrieve full-text PDF files. While these features are great, there are also limitations of using reference manager software in systematic reviews. Firstly, software such as EndNote does not allow version control, so it can be hard to see and keep track of your records from your initial search down to your included studies. Workarounds can include having separate files for all of your retrieved references, your unique references, and your included references, or splitting these up into groups in one single file, but these can be hard to keep track of. Secondly, it's easier to make user errors. You might accidentally delete data or lose a reference. From my own experience using groups, I know how easy it can be to click move to trash instead of remove from group. Finally, although software such as EndNote are called reference managers, they are built for keeping track of references in the paper that you're writing or your thesis, not working through the various stages of a systematic review. So what are the benefits of using R instead? For me, a major benefit was greater data management and reproducibility. I can write R scripts which run through my entire systematic review, from importing my searches to analysing my results. Everything is all in one place and it's a lot easier to reproduce and redo. Errors can still happen. For me, typos in code are really common, but these types of errors are so much easier to pick up and check, meaning that they can be fixed really easily. Something that makes using R in systematic reviews really powerful is the fact that there are so many purpose-built R packages and a growing community of coders contributing to these packages. Coding is generally a useful skill to learn, but in terms of a systematic review, it offers so much more flexibility to what you can do with your data. There are a lot of R packages available to help you through the various steps of a systematic review project. I've listed here some R packages which can perform similar functions to what you'd find in reference management software. Starting with searching or importing your search files, the synthesize R package allows you to import bib files from your database searches directly into R. There are also a variety of packages which allow you to perform systematic searches within R itself. This is a particularly useful solution for living evidence synthesis projects. These packages include RISMed for PubMed and medRxiv-R for medRxiv and bioRxiv. Moving on to duplicate removal, both the synthesize R package and the assist package have functions which enable removal of duplicate records. Assist was actually developed by my colleague Dr. Kaitlyn here, and the validation of Assist found that it outperformed EndNote's own duplicate removal function. Finally, there are various packages which enable automated retrieval of PDFs. medRxiv-R can be used to retrieve full text from medRxiv and bioRxiv. ROADOI retrieves free full text available via unpaywall, and rCrossref retrieves from Crossref. To run back over the key points of this talk, I hope that I've been able to convince you of the many benefits of using R in systematic reviews over typical reference management software, especially in terms of data management. And I've also introduced you to what is a large and growing community of R enthusiasts, all producing purpose-built tools for systematic reviews. Thank you for listening. I hope that you found this introductory talk useful, and if you haven't already, you'll consider making the switch to using R in your next systematic review project. If you have any questions, please do get in touch.
Thanks very much, Emma. Up next, we have Claudia Capp, who is going to be speaking about text analysis for search strategies, implementing an approach with R.
Hello, my name is Claudia Capp. I'm from Germany and work as an information specialist at IQWiC, the Institute for Quality and Efficiency in Healthcare. This talk is about the package that we're currently creating for search strategy development using text analysis. I will give a brief introduction for the use case and workflow of the package, and afterwards I'll show you the current status of the Shiny app in the package. To conduct a systematic search for evidence synthesis, a search strategy is required which returns a reproducible result. The goal of the package that I will present today is to help identify the relevant terms empirically, to create a concise but sensitive search strategy, to find all potentially relevant studies. Our information retrieval team at IQWiC has been searching for a new tool for a while now. During last year's ESMARConf, my colleagues discussed a few key points that would be relevant for our team in order to be able to use a new tool for our search strategy development process. Our requirements included a graphic user interface for the app, that our IT security team had to be on board with the suggested tool, and in order to be able to exchange ideas with other researchers, the tool should be open source. A Shiny app would actually meet all these criteria. So just a hint for you to find out more about the discussion on automation and information retrieval, go check out the panel discussion that was joined by my colleagues Elke, Hausner and Sieben Waffenschmidt on last year's ESMARConf2023. It's called Building an Evidence Ecosystem for Tool Design. In terms of functionality, we actually did identify some R packages that could do what we needed for our workflow. The problem was that they would require quite a lot of R skills to handle our use case, and not all of our information specialists feel comfortable using R without a graphical user interface. So in our Shiny app, we basically created a customized workflow using a bunch of other packages that already exist. The packages that we currently use most heavily are dplyr and tidyr from the Tidyverse, RefTools from the Metaverse, and of course Quantata, which is a bunch of packages designed for quantitative textual analysis. And finally, we also use Shiny to create the user interface. To understand what our Shiny app actually helps with, I will very briefly describe the process that we use to develop a search strategy, and specifically, I will introduce the concept of overrepresented terms. So Let's imagine a very simplified example. Usually, a search strategy development starts with a test set of already familiar publications of studies. These serve as a gold standard. I will not go into detail on creating a test set here. This could be a complete presentation all by itself. Having identified a test set, next step is the frequency analysis of terms in this gold standard of references. This is to see which words occur in all or most of the references that we aim to find in the systematic search. For example, in this example, fake word cloud, participant and randomized appear equally frequent, and one might thus expect them to be equally good search terms. On the other side, the and of are obviously frequent but irrelevant terms for a search, while control and placebo are not as frequent. This means that the mere frequency of a term does not tell us yet whether it is also a good search term in a specific database. And here's why. Imagine that we want to search for studies in PubMed. In this simplified example, all our relevant references are indexed here. So let's check the terms from our example frequency analysis as search terms in PubMed. Some terms like participants would find all relevant references, but it turns out that they occur also very frequent in the database in general. This means that these are frequent terms in our gold standard, but compared to all indexed references in the database PubMed, the terms are not more frequent in our gold standard and thus not very specific or precise. Let's check another term in our gold standard. This looks much better. The terms occur in all of the relevant references, but it's not frequent in the target database PubMed. This makes it overrepresented in the relevant references. To sum up, the goal is to identify those terms that are overrepresented in the test set so they appear frequently in our gold standard, but they are not frequent in other references in PubMed. To find these terms more readily, we created our R package. It aims at identifying overrepresented terms, those terms that are sensitive for finding relevant references and that are also precise, so they do not retrieve many irrelevant references in the search result. Next up, I'll walk you through the workflow in the Shiny app of our package. First of all, one imports a RIS file with a set of references, the gold standard. Next up, the package automatically conducts a frequency analysis of the terms in title and abstract and compares them to a random sample of references from the Medline database. In the end, you can download a CSV to continue working with the results outside the app. The Shiny app has multiple tabs. In the tab Data Import, you are prompted to upload a test set, which has to be in RIS format. If the upload was successful, the references, accession numbers, authors, titles, and keywords are displayed in a table. To continue with the statistical analysis, click on the action button Analyze All References. We're also planning to implement a function to automatically split the test set into a development set for term harvesting and a validation set for a bias check of the identified search terms, but that is not implemented yet. After clicking the action button Analyze All References, switch to the next tab, Free Text, to see the results. All words are listed, punctuation is removed, but stop words like the, of, and are kept. Next, it is possible to download a CSV file to work with it more flexibly. Be aware that this is currently a German CSV with semicolons as delimiters and commas for decimals. The terms that appear in the test set are compared to the frequency of the term in the random sample of PubMed references. The random sample is part of the Shiny app. The table displayed is sorted according to the z-scores, which is the test statistic of the comparison against the PubMed sample. This means that the overrepresented terms in the test set are on top of the list. I'll skip the options for analyzing mesh data. If you're interested in this option, please contact me in the online Q&A or on GitHub. Let's stay with the free text terms and pick a candidate for the search strategy. In this example, the most overrepresented term appears to be the acronym IQWIC. Maybe you're not aware what this stands for, so let's see the keyword in its original context. This is possible in the tab Keywords in Context. Just type in the term that you are interested in. The resulting table lists all the occurrences of the term in its original context. You have the option to customize the window of words around the term of interest. It is also possible to truncate terms. So in this example, the term search with an asterisk will find all occurrences of search and its plural searches. The last tab Phrases offers the functionality to explore n-grams to search terms that consist of more than one word. Here you can find out how many words are in between two terms of interest. In the first example, you can see that phrases search strategy and search strategies always appear as a 2-gram in the test set, which means that they never occur with a word in between. The second example shows all the n-grams for the term non-inferior. So on top of the list is the frequency of the two terms non-inferior and conceptual as an n-gram. And the table tells us that they only appear as a 4-gram. So in our test set, the two words non-inferior and conceptual only appear with two other words in between and never directly next to each other. This is actually very helpful in order to determine adjacency operators for a search strategy. So now you know what our package does. You can find it and the source code on our GitHub repository. Well, there's still a lot of work to do, and thus it's not yet possible to install the package from GitHub, but we're definitely planning to do that very soon. So what are our next steps? We're currently working on finishing version 0.1, and the plan is to release it on GitHub in the first half of 2023. We are planning for version 0.2, where we also want to rethink our own workflow. We're very interested in feedback from others and from you who work with evidence synthesis, and so our long-term goal is finally to release our package on CRAN. So in case you would like to get in touch about our work, feel free to contact me either via Mastodon or GitHub. And of course, there's also options for posing questions during the ESMA conference as well. So thanks a lot for watching this talk and have fun.
Thanks very much, Claudia. Up next, we have Chiang Zhang, who's going to be speaking about Paperfetcher, a tool to automate hand searching and citation searching for systematic reviews.
Hi, everyone. I'm really honored to be presenting at the ESMA Conference 2023. The project we are presenting today is called Empowering Systematic Reviews with the R version of Paperfetcher, effortless hand searching and citation searching at your fingertips. So my name is Chiang Zhang. I'm a PhD student at Johns Hopkins School of Education. I will take care of the first half of the presentation, whereas Akash Pallath will take care of the second half of the presentation. This is today's presentation agenda. I will first introduce what is hand searching and citation searching. Then I will talk about why do we need a new tool, and I'll explain whether there are other tools before I introduce Paperfetcher. So, literature review. Literature search and review lays the foundation for most research. How do you search for relevant literature? I'm sure some of you may have used Google Scholar, ERIC, or PubMed. For this type of searches, we call it the database search. This is the most common search technique, whereas there are some other supplementary search techniques. And one such supplementary technique is called hand searching. Hand searching means manually browsing through the tables of contents from journals and conference proceedings. For example, this journal called Research Synthesis Methods. If I want to conduct hand searching on this journal, I will browse through each volumes, each issue, and look at the table of contents to identify relevant articles related to my research. Another supplementary search technique is called citation searching. There are two directions in citation chasing. There is a backward citation chasing, which is also called reference tracking. There's also the forward citation chasing, which is also called citation tracking. Citation chasing is important. Researchers have found that citation searching identifies 51% of studies in systematic reviews. For forward citation searching, take Paperfetcher as an example. Forward citation searching means studies cite Paperfetcher. Backward citation searching means if you open Paperfetcher's publication and scroll down all the way to the last reference page, backward citation searching means all the papers Paperfetcher has cited. So why do we need a new tool? Broadly, there are three reasons. The first reason is that there's a rapid increase in studies available online, and therefore there are more papers to retrieve. The second reason is that the manual search is time-consuming, laborious, and costly. From past research, time spent on this type of search ranges from 1 hour per journal's volume to 185 hours per 10 journals. The third reason is that it's error-prone and lacks replicability. Because we are humans, the type of manual search makes us tired, and it's easy to make mistakes when we are tired. It also lacks replicability and an easy cross-checking mechanism. Naturally, the next question you may want to ask is, are there other tools that we can use? The answer is yes, but they are limited. So the first tool is called SciFinder. SciFinder enables backward citation searching. However, it is not free, and it focuses on natural science literature. The second type is called databases. They include Web of Science, Scopus, and Google Scholar. They are difficult to download in bulk and different formats. SpiderCite and Citation Chaser are free and of better features. However, to date, all the above tools do not automate hand searching, and that is the main reason for us to develop Paperfetcher. Now Akash will introduce Paperfetcher in R.
All right, now for the fun part. Let's do a quick demo of Paperfetcher in R. Now, in the interest of time, we are going to go through a very quick example of hand searching using Paperfetcher. So what we're going to do is we're going to retrieve the metadata of all articles from the following two journals, the Journal of Youth and Adolescence and Research Synthesis Methods, published between January 1st and February 1st, 2023. We're going to retrieve this metadata in the RIS format, which is a format that's easy to import into various citation management tools such as Zotero, and also into systematic review screening tools such as Covidence. All right, so let's now move to our code. Paperfetcher at its core is a Python package. What we're going to do is use an R library called Articulate to call the Paperfetcher Python package within R. Now, this involves a couple of steps of setup. We first need to install Articulate. If you don't have Python installed, you're going to have to do that. If you don't have Paperfetcher installed, you're going to have to do that. We're not going to need to do all that. We just need to sort of import Paperfetcher before that install Articulate. Let's get that done. The next step is to specify a list of ISSNs, which we want to, hand search in. Specify sort of the date range we want to search within. And, Paperfetcher also has the option to filter our search results using a bunch of keywords. We're not going to do that here, but that's also an option you can consider. So let's run this. And now let's get to sort of our hand search. Let's run all of this code, and then I can explain what it's doing. So what we're doing is we're looping over all the ISSNs we specified, and we're performing hand searches for each of these ISSNs. We're constructing a data frame of, the metadata that we fetch, and we're also constructing RIS files of all the metadata that we fetch. So we first already finished searching through our first data frame. And yeah, we're now done searching for our second journal. And if you click on this, you see we've got a nice data frame here consisting, of all the metadata that we fetched. We've also got these two RIS files. This is the data that we got from hand searching. Yeah. Now this script, and also some other scripts for citation searching are available on our GitHub page. Here's the link. Definitely check these out, as you know, these are almost ready to use. You just need to change a couple of parameters. And if you're interested in learning more and also in understanding how this hand searching and citation searching code works, we've got some R notebooks that explain the different steps and the different segments of code in depth. These are interactive notebooks. You can play around with these, get more comfortable with using Paperfetcher. In summary, Paperfetcher is the first user-friendly tool to automate hand searching. It is free and open source, and it can be used by researchers in any field. If you want to learn more about Paperfetcher, please read our paper, which was published just last year in Research Synthesis Methods. You can always contact us, email us or reach out to us over Twitter if you have any questions about Paperfetcher. And also check out our web app. Here's the link, paperfetcher.github.io. You can scan the QR code. And definitely check out our GitHub page. We'll keep updating it as and when we add more resources about Paperfetcher to it. Thank you.
Thanks very much, Qiyang and Akash. Up next, it's me. I'm going to be talking about GSscraper and greylitsearcher, which are useful but flawed tools for searching for studies in evidence syntheses. Hi, and welcome to my talk. My name is Neal Haddaway, and today I'm going to talk to you about two apps that I've built for grey literature searching called GSscraper and greylitsearcher. And I'll hopefully show over the next 10 minutes that they are potentially useful but flawed tools for searching for studies in evidence syntheses. So before we get started, I just wanted to give a definition about grey literature, of what it is. And it's been defined as any literature which is produced on all levels of government, academics, business and industry in print and electronic formats, but which isn't controlled by commercial publishers. So that's where publishing is not the primary activity of the producing body. And it's things like theses, organizational reports, white papers, and consultancy reports. And it's important for any review that wants to be rigorous, because you're looking here for comprehensiveness, and there's often a lot of really useful information that just wasn't aimed to be published in an academic audience. And it depends on your subject area, obviously, but there are some systematic reviews where 25 or 30% of the evidence base in the final review is grey literature. And traditionally, greylit searching is done manually. So people go to Google or other websites and search manually and only record when they find something relevant. So then we don't know how they went about searching, perhaps. And even if they did report what they did, it's very difficult to then repeat it. So it's very laborious and largely unrepeatable. So I built a couple of tools to help. The first one is called GSscraper, and the GitHub repository and Shiny app link are there in the top right. And the way that GSscraper works is to make use of the fact that Google Scholar creates a URL with patterned information that come from your search. So it's very easy to build a functional Google Scholar URL just using search terms. And that will then take you to a specific page with a specific search. And if you play around with a Google Scholar advanced search, you can see all of the things that you can put in, including authors, phrasing, whether to include citations or not, what the journal is that you want to search in, and years and stuff like that. And the way that Google Scholar, the way that GSscraper rather works is to first of all build all of these links based on the number of pages you want to search from and up to. It then saves these results and scrapes the code within the HTML files. And then you can download it as a CSV or an RIS. And in the case of GSscraper, you can publish that search to Zenodo as a citable search history. And the good thing is part of it works. So the first part, where we're building functional URLs, works really well still. And it actually does download the HTML files. The problem with GSscraper is that those HTML files are then held within the app. And the next part doesn't work, which is the part where it's scraping the code. So you can see the website with the Google Scholar search results on the left panel here. And then on the right, you can see the source code. And the problem is that the code that Google Scholar uses just fluctuates over time. And the problem is here that there's one specific code in the code that I've written that is using regular expressions to find the code GS_RI, which indicates each one of the 10 search results on the page, and that code has changed. So something within the website code has altered. The next tool that I built was called greylitsearcher, and this is very similar to Google Scholar and GSscraper, but just on Google. And the way the way that this works is that it searches a given website. So let's say you want to search the Stockholm Environment Institute website for the phrase climate change. Well, you can search that site using Google Scholar's site search. And it does the same thing. It builds the links, it downloads the HTMLs, and then scrapes the search results as a CSV file in this case, and lets you download the data. The first part works very much the same as GSscraper. It will download, or it will produce functioning URLs based on your search terms for each website and for the number of pages of results that you want. And actually with greylitsearcher, I've built in some extra code to let you download the HTMLs before it starts scraping them, which I didn't get around to doing in GSscraper. So you can transparently document your search, but you'd still then need to manually go through and screen everything. But again, the problem here is that the code that I've used to break up the Google search results is quite complex, and it's easily changed. So this doesn't work as well. And so what I could do with both of these tools, and I was doing for a while, was to go through and unbreak them whenever the code changes, which requires quite a bit of time to play around and work out how it's changed. Unfortunately, I don't have that time anymore. I'm not an employed scientist. I've changed career, so I don't have time to fix the app, and I'm really sorry, because I can tell that people are accessing it and trying to use it, and I know that's frustrating. A longer-term solution to get around it is to avoid using regular expressions, which would mean that it might be able to use the structure on the web page rather than the underlying code, which is more likely to change in a very small way. And I don't know quite how to do that in a sort of future-proof way, so I really need some help there. So yeah, if you are willing to help and have time, perhaps to take over or to join a team, I'd be really happy to chat to you, perhaps even convene a hackathon over the next year maybe, or a hackathon at our next evidence synthesis hackathon event. If you are interested, you can drop me a DM, a direct message on Twitter, or you can raise an issue and just say that you're keen to take over. If you really want, you could actually start trying to fix it on GitHub by forking one of the repositories and having a go at fixing the code. I'd really appreciate that, and that might be a really efficient way to do it. Or you can drop me an email. So if you're interested in a longer term hackathon and you've got some time, but perhaps don't have time to fix it yourself, maybe that's a solution. But yeah, thanks for your interest in the tools. I really appreciate it. I can see people trying to access it, and I'm really sorry that they're not currently working, but I'm really trying with the resources and time that I have to find a longer term solution. Thanks again. Thanks very much to all our presenters today, and thanks to you for coming along to this session. We hope that you enjoyed it. Our presenters will be online over the next few hours and days to answer your questions, so do please keep them coming in via Twitter. And we hope you enjoy the rest of the conference.